Welcome. Today we're going to be doing experiment 2 of organic chemistry, so it would be Chem 3220. And we're going to be doing the Grignard synthesis of benzoic acid. So we're going to be starting with bromobenzene, add in our magnesium to get this magnesium bromide species. Then we're going to react it with CO2 and an acid to create our benzoic acid. So now that we know what we're doing today, as far as Grignard synthesis, the glassware that we're going to be utilizing today is we need our 2 test tubes. These are going to hold all of our reagents and things like that. We're also going to need a glass stir rod. This is going to be useful for grinding up our magnesium, getting our reaction to start, so that way we can actually synthesize our compound. So this is going to be helpful. And then we're also going to need a Buchner funnel for later in the reaction, as well as a syringe to add all our reagents, and septa to seal up all of our test tubes to keep everything air free. Now, these are just examples. We're going to be utilizing stuff out of the oven, and that brings me to kind of our first question, is why do we have to have all this stuff be dry? Well, that's pretty simple. For the Grignard experiment, magnesium bromide complexes are very reactive as bases, so they'll pull off a proton from anything, so including water, and create just a simple benzene. So this could be a potential product if we do not keep all of our stuff nice and dry. So we have gone ahead and we've weighed out our magnesium, and we've added it into our test tube 1. So we've got our 0.048 grams or 48 milligrams of our magnesium added to our nice dried test tube 1. All right, so to that test tube, we're going to take and we're going to add 0.5 milliliters of diethyl ether anhydrous. Remember, it's important to keep all of our stuff here dry to ensure that we don't create benzene during our reaction. So we're going to add 0.5 milliliters of diethyl ether, and we're going to seal back up our test tube 1. Later we'll uncap this again, but we're also keeping our diethyl ether from dissipating out into the fume hood, as well as we're keeping as much air and moisture out of here as possible. Alright, so also we need to add to our test tube 2, which we've just taken out of the oven, we need to add 0.25 milliliters of bromobenzene. We're going to use here our little stopper. Alright, we got 0.25 there. Alright, we got 0.25 milliliters of bromobenzene, and we're going to add up to 0.75 milliliters or 0.7 milliliters of diethyl ether. So we'll get us about to the 1 milliliter mark. Right here. So now we have our solution ready to add to our magnesium. Okay, so what we're going to do here, we're going to cap this with our septa. Boogers are hurting me on here. Add our septa, we're going to give it a nice shake. Okay, kind of get everything nice and mixed up. And then we're going to move on to adding everything. Now that we've got our diethyl ether bromobenzene mixture, what we're going to do is we're going to take a syringe with a needle, and we're going to puncture our septa. We're going to turn this over, all right, and we're going to draw up all of our reaction mixture, or all of our mixture here from test tube 2 to use in the remainder of the experiment. So got our air bubble there. So we've drawn up all of our compound. Now comes the tricky part. We've got to take and we need to add this to, we need to add 0.1 milliliters of our solution to our magnesium. So this will be test tube 1. Okay. So here what we're going to do is we're going to puncture it with one of our, with an empty needle, and puncture again with our other one. We're going to add in, this has no measurement marks, but whatever, 0.1 milliliters of our bromobenzene solution. And so then we're going to save that for later. What we can do is stick this here. And what we're looking for here is we're looking for any bubbles in the magnesium, and we don't see any. So what we have to do now is we're going to remove our needle from the top and take off our septa and start stirring with a glass stir rod. What we're going to have to do now is we're going to have to kind of grind the magnesium in order to get the reaction to occur. So how to do this is we're going to take and we're going to place this on top of a bed of paper towels so we don't bust through the bottom of our test tube and ruin our reaction. And we're just going to kind of grind up the magnesium and stir it up and get it going till we can cause some bubbling to form, hopefully. Any bubbling yet? Nope. So we keep going. You ready? Mm-hmm. Alright, so after stirring this for about 5-6 minutes, what we ended up doing is you can notice we have bubbling occurring in our solution. So now we're actually creating the magnesium bromide. So what we can do now is again place our septa back on top of our reaction. And we are going to place our needle in the top, our empty needle. Why would we need to do that for this reaction? Well, we're also creating a gas in this step of the reaction, so we need to be able to vent our reaction vessel. Otherwise, it could blow up or our lid will pop off and ruin our reaction. So now, what we're going to do is we're going to add our bromobenzene solution that we got earlier and created earlier, and we're going to add this drop-wise over 10 minutes. So, now our reaction is complete. Okay, we observed no more bubbling with our magnesium bromide solution, so we created our Grignard reagent. Alright, so now it's time to react that with our CO2. And our CO2 source that we're going to be utilizing is dry ice. So, dry ice is very cold, so what happens is the surface is condensing moisture. So what we need to do is we need to take and pat that off with a paper towel, so that way we don't have the chance of forming any benzene, or we reduce the chance, rather. So place this back into our beaker. Then we're going to go ahead and we're going to take and pipette out our solution here with our Grignard reagent. And here what we're trying to do is we're trying to reduce the amount of magnesium that we actually add onto our dry ice, because later we're going to take and add base and pour that into our Buchner funnel. So here we're just going to take all of our reagent, try to avoid pulling up any magnesium. Did pretty good. And we're just going to drop it onto the surface of our dry ice. And as you'll notice, you kind of hear some fizzing and things like that. That is the reaction occurring. And what we'll end up seeing later when we add our acid is we'll see a nice white precipitate. So it's important to note during this step of the reaction that we should also add the drops directly onto the CO2, so onto our dry ice, to make sure we get maximum yield. If we add it around the CO2, we don't get the same contact and the reaction doesn't occur as efficiently. So another question is, why would you have to add our reagent directly onto the dry ice? Okay, so now that our dry ice is evaporated, we've created our benzoic acid. What we're going to do is make sure that we get the highest yield possible, don't have any of the benzoate salt. So what we're going to do is we're going to take our hydrochloric acid and we're going to add a little bit of this until we have an acidic solution of our benzoic acid, etc. So how we're going to test this is we're going to use pH paper. So take a piece of our pH paper here, small piece, doesn't have to be a whole lot, and looking at our scale, what we're going to do, we're going to stir this up, drop it onto our pH paper here, and then compare our scale here. So that's acidic to me, around 1, so we should be good. Our reaction with our Grignard reagent and the CO2 has occurred. What we need to do now is we need to turn on our hot plate. We'll go ahead and plug it in. We're going to plug in our hot plate and we're going to set it to 50 degrees. This is just enough that we'll get the diethyl ether to come off while preventing our benzoic acid from subliming. Because if it sublimes, we're going to lose product. Now we are just going to place our reaction mixture. After all of our dry ice is sublimed, we're going to get rid of our diethyl ether. We set our hot plate to 50 degrees. That's enough just to get the diethyl ether to remove, but leave behind our benzoic acid. Alright, so we've dried off all our diethyl ether. Now we need to use something to get rid of our excess HCl. What could we possibly use? Well, in the experiment, it's got us washing this with water. What this will do is it'll allow us to be able to wash our product as well as be able to get it out of this thing. So we can pour it directly in the Grignard funnel, get it dry. So we're kind of getting 2 birds with 1 stone type of thing here. So we're going to wash it with a little bit of water. All right. We're going to break away the rest of the benzoic acid stuck into our beaker with our spatula. You could use a glass stir rod, whatever you want to use here. Just try to get all your product as much as you can, so that way we have enough to get a yield as well as do a melting point. Alright. So after we've got it good and scraped out of our beaker here, and it's all kind of suspended in our water, what we're going to do from here is we'll go ahead and turn on our Grignard funnel. Turn on our Grignard funnel, and we'll begin to filter our water and benzoic acid mixture. If you got to wash a couple times with water, no problem. No problem at all. Want to make sure we get as much as we possibly can. Scrape out some of what we have left in here. Put it right in there. Do another wash. Scrape a little more. I want to get all this out of here. Also, the more times we do this, the more we wash off all of our excess acid, give us a more accurate melting point. Alright. So now what we're going to do is we're just going to let this pull vacuum for a little bit. It'll dry some of our crystals for us. Everything is nice and dry. And yeah. So why would we need to rinse our product with water? So now that we've let our benzoic acid dry, okay, so what we're going to do now is we're going to make sure it gets completely dry. We're going to do the press drying method. So we're going to take a piece of filter paper, okay. We are going to take a piece of filter paper and we are going to fold it in half. Then we're going to take our benzoic acid, scrape it off the frit on the inside here. Get it onto our filter paper. Get as much as we can. Remember, we're after the highest yield possible. Alright. Now that we've got our benzoic acid scraped out of our Grignard funnel, what we'll do is we'll take our piece of filter paper, fold it over, place it between a couple paper towels, like one like so, between another one, like so. And we're just going to press out the filter paper. Try to absorb any more moisture we can. We want as much moisture out of here as possible. And why would that be? So what this will allow is for us to get the most accurate melting point possible. We don't have water interfering with our melting point. And as you can see, we've got a little spot of water here. So we'll just repeat this process until we don't see that. So now we've got our product dry. So we're going to go ahead and we're going to scrape it onto a teared piece of whey paper. Here we're going to tear it out on the balance. Now it's zeroed out. We can take our piece of whey paper. We can scrape our product onto the whey paper. So from there, we can place our whey paper back on the scale and see how much we obtain. So we ended up with about 35 milligrams. So now we'll take our melting point and see how pure we got. Now we're going to add our product into our capillary tube so we can take our melting point. Key here is that we get enough to get an accurate melting point. So we want to make sure we have about 2 millimeters or so worth of material that we can get down into our capillary tube. So right around that much. Alright, now we're just going to tap it down until we get to the bottom. This is one of the longest portions of the experiment. But we're making quick work of it. All right. So now we're ready to do our melting point. So first drop at about 114, and we have melted at about 115, 116. So based off of our melting point, we are pretty darn pure because we have a very short melting point range. So there's a few things that could be wrong. Maybe the thermometer is not completely calibrated correctly, things like that. We could run a standard beside it to see whether a thermometer is correct. But here, based off of the distance of our melting point, we have a very pure product. All right, everyone. So that concludes our experiment 2, Grignard synthesis of benzoic acid. Hope you enjoyed it. Thank you.